In this video, I'll show you how to use JUMP to conduct a hypothesis test for a population proportion. So we're going to go back to the sample data menu that we used when we were doing confidence intervals for a proportion. So that's under Help. Remember, we go down to Sample Data, and then we go back to our calculators. And this time the calculator that we're going to be using is hypothesis test for one proportion. And again, we have to choose between raw data or summary statistics. So you use raw data when you have a data file that has one row for every individual surveyed. So in this case it would be yes, you believe in global warming, or no, you don't. But we didn't have that. We just had a summary of how many did say yes in our sample. So we choose summary statistics. Alright, so I'll be working through how to do this using the global warming example from the notes. And the first step is to choose your alternative hypothesis. So the first choice is the two-tailed approach. The second choice is less than, so that would be the left-tailed approach. Or the third choice is greater than, so that would be right-tailed. So if you remember the global warming example, we were just curious whether or not the proportion had changed, so that was a two-tailed example. Next, we come over and fill in the test inputs. So our hypothesized proportion is going to be the value of p sub 0, so the value in the null that we're assuming to be true in the null hypothesis, so that's going to be 0.58. We're assuming there's been no change from the historical rate. The number of successes is how many people said yes, I believe there has been a change in our sample, so that would be 551 out of the 1,011 people who were surveyed. And then finally we have to input our significance level, and if you remember, this was a 5%. And then we can click Reveal Decision. Now we can see the test results have filled in. So the estimated proportion is going to be the value of p hat. So that's 0.545, which is 551 divided by 1,011. Next, we have what's called the z-critical value, and we're really going to ignore that. But you'll notice that that's the 1.96 that goes with a 95% confidence interval. And what we're going to talk about next is how confidence intervals and hypothesis tests are related. Then we have, the next thing we're going to be interested in here is the test statistic, which is negative 2.2545. And then our p-value is reported to be 0.0242. So you'll notice that's a little bit different than what we got when we did it by hand. We got 0.0244 from the table. However, what you get from JUMP is a little more precise. Remember, our table is limited by the fact that it can only give probabilities for, up to 2 decimal places of the z-score value. Well, JUMP can calculate probabilities for even more decimal places of the test statistic. And so what you get from JUMP is a little more precise. But we see that the decision is reject the null, which agrees with what we did when we worked out all 5 steps of the hypothesis test by hand.